Welcome back. Still under limit. This will be the last approach we'll be dealing with under limit. So if this is your first video under limit, please, you are in the wrong place because we've done 5 approach behind. So you can go back to those previous videos and watch the 5 approach we've done under limit. So this is the last approach we'll be dealing with under limit. This is the last approach. Now, question says evaluate the following. Limit as x tends to 0, x minus sin x over x plus x squared. Question 2, limit as x tends to 0, 1 minus cos x over x squared. Question 3, limit as x tends to 0, 1 minus cos x over 2. Question 4, limit as x tends to 0, x squared plus x raised to power 4 over x minus sin x. You know the way we used to do it now? You solve question, I'll solve question 1 and 2, you solve question 3 and 4. So I'm solving the one on black, you're solving the one on red. So please, to solve this method now, to solve this question now, which approach are you going to be using? Now let's go to the question. We have question 1. Limit as x tends to 0. We have x minus sin x over x plus x squared. Now, you know everyone's choice is always trying to what? Trying to use the direct approach. Now let's try the direct approach if we are going to get our answer. X tends to 0. Let's put 0. That will be 0 minus sin 0 over 0 plus 0 square, right? That will be 0 minus sin 0 is what? 0 over 0 plus 0, which will give us what? 0 over 0. And what is it called? Undefined. So this is called undefined form. Means it can't go like that. So how do we do it? Can we use the previous approach we've used? Can we use the factorization method? No. What do you want to factorize? Can you use the, which other one do we use again? Dividing through by the highest power of x? No, it doesn't look like that. Can we rationalize? No, it doesn't look like that. Can you expand? No, it doesn't look like that. So what's the last approach you can use? Which other approach can we use? Is what? To solve this approach. Okay, let me just tell you the approach first. So it's using L'Hopital's rule. Using what? L'Hopital's rule. And what is L'Hopital's rule? L'Hopital's rule is all about differentiation. You have to differentiate it. Sure you get. So meaning that before you can solve questions like this under limit, you have to know differentiation very well. So please don't worry. For you to understand differentiation very well, after this video, the next video will be all about differentiation. We'll go into differentiation in full. Sure you get. We'll go into differentiation in full where you understand differentiation very well. But if you don't understand differentiation, you will not be able to solve any question that comes like this under limit. You will not be able to solve it because it's all about differentiation. And don't forget something. L'Hopital's rule is all about differentiation. Don't forget. And take note of something. I said something. When you are solving limits, your denominator must not be what? 0. That's the aim. Your denominator must not be what? 0. So let's solve using L'Hopital's rule now. Now let's differentiate. So we'll still have our limit as x tends to 0. When you differentiate x, what do you have? 1, right? Then minus, when we differentiate sin x, what do we have? Cos x. When we differentiate x, what do we have? 1. Plus, when we differentiate x squared, what do we have? 2x, right? So let's insert. You insert your limit. So if your denominator does not give you 0, sure you get, then you are good to go. But if your denominator still gives you 0 after differentiating the first time, what do? You differentiate again the second time. That's it. If your denominator does not give you 0 when you differentiate it the first time, you are good to go. But if it still gives you 0, then what do? You have to differentiate the second time. If you differentiate the second time, it still gives you 0, you differentiate again the third time. If it still gives you 0, you differentiate again the fourth time. You keep on differentiating till your denominator does not give you what? 0. That's the aim about limit. The denominator must not be equal to 0. So let's insert and check if our denominator does not give us 0. So that will be 1 minus cos 0 over 1 plus 2 times what? 0. Now, that will be giving us 1 minus cos 0 is what? Cos 0 will give us what? 1, right? Over 1 plus 2 times 0 is what? 0. 1 minus 1 is what? 0 over 1 plus 0 is what? 1. You see that we are good to go. Why? Because our denominator is not 0. Sure you get. The aim of limit, don't forget, is to what? Your denominator must not be equal to 0. So 0 divided by 1 will give us what? 0. And that's the final answer. It's not like you cannot have 0 as an answer. You can have 0 as an answer, but your denominator must not be equal to 0. That's limit. Your denominator must not be equal to 0. And you must not have all these indeterminate forms. That's all about limit. Shey you get? So our final answer is what? 0. Now going to question 2.